Viewers, today we're going to be looking at another higher mathematics called implicit function. Implicit function. What is an implicit function? An implicit function is a function in which the dependent variable and the independent variable are critically involved. In other words, if you have, for example, you have y equal to x plus 5. Now the value of y depends on what x is given. So this type of function is called an explicit function. Explicit function. Then we have another function. Take for example, we have x squared plus y squared plus 3 equal to 4, for example. Now this type of function here, the value of y does not depend on what x is given, does not depend on the value of x. The value of x and the value of y are completely independent of each other, and it is very difficult to separate both of them. When you have a function like this, it is called an implicit function. Implicit function. And you can solve a problem of implicit function using what is called implicit differentiation. Implicit differentiation. So look at this question on the board. It says find dy dx if this is this. So here is an implicit function, and we can only solve this problem using implicit differentiation. Now in implicit differentiation, the rule is this. You are differentiating with respect to x. Don't forget, I repeat, you are differentiating with respect to x. So let's go. Solution. Rewrite the question: x squared plus y squared minus 2x minus 6y plus 5 equal to 0. So we differentiate with respect to x. If you differentiate x squared using the principle of differentiation, you have 2x. Differentiate x, you have dy dx. Plus, if you differentiate y squared, you have 2y. Then when you differentiate y, because you are differentiating y squared with respect to x, if you differentiate y itself, you have dy over dx minus, then you have 2x. If you differentiate 2x is 2. If you differentiate 6y minus 6y, the derivative of 6y gives you 6 attach y dy over what? Dx when you differentiate y itself. Plus the derivative of 5 is 0. 5 is a constant. So the derivative of a constant is 0 by the law of differentiation. So now let's bring the dy dx, let's bring them together. We have 2y dy over dx minus 6 dy over dx, then plus 2x minus 2 equal to 0. Dy dx is common here. We factor it out. Dy over dx bracket 2y minus 6. Then we take this to the other side. You have 2 minus 2x. So divide both sides by 2y minus 6 to get dy dx. So we have dy over dx becomes 2 minus 2x over 2y minus 6. So if you factorize 2 out from this numerator, we have 2 bracket 1 minus x over, bring out 2 here, you're left with y minus 3. So 2 dematerializes 2. Your final answer, dy over dx, becomes 1 minus x over y minus 3. So this is what is called implicit differentiation. This is what is called implicit differentiation. Now let's look at another example briefly again. Another example to learn more on this. Find dy over dx if x squared plus xy plus 3y square equal to 4. Now here is another example. Solution. We apply the same principle. Rewrite the question: x squared plus 2xy plus 3y squared equal to 4. We differentiate each term with respect to x. If you differentiate x squared, you have 2x. If you differentiate 2xy, don't forget 2xy is in a product form. Two variables combined together in a product form. You apply the principle of product law, product rule. I have explained product rule in the previous video. So you go back and check how I explained product rule. So we are going to apply product rule here. So plus, bring out the constant 2, open bracket, put down the first one, differentiate the second one. If you differentiate y, you have dy over dx, plus bring down the second one, differentiate the first one. If you differentiate x, you have 1. This is product rule. Then plus 1 to differentiate this. If you differentiate 3y squared, you're going to have 6y. Differentiate y, you have dy over dx, because we are differentiating 3y squared with respect to x. So you attach dy dx. If you differentiate 4, is 0, because 4 is a constant, and the derivative of the constant is 0. So let's open this bracket. You're going to have 2x plus 2 times x dy over dx plus 2 times y times 1, which is 2y, plus 6y dy dx equal to 0. So let's rearrange by bringing the dy dx together. You have 2x dy over dx plus 6y dy over dx plus 2x plus 2y equal to 0. I only rearrange them. Now factor out dy dx. I have dy over dx bracket 2x plus 6y. This is what you have. Then we're going to take this to the other side, which is minus bracket 2x plus 2y. So this is what we're going to have. So we'll divide both sides by 2x plus 6y to get dy dx. Let's continue from here. I'm going to have, therefore, dy over dx is equal to minus 2x plus 2y over 2x plus 6y. 2x plus 6y. You can bracket it if you like. So let's factor it out. Dy over dx is equal to, what is common? 2 is common here, minus 2. If you bring out minus 2, you're going to have x plus y over, if you bring out 2 again, if you bring out 2, you're going to have x plus 3y for this denominator. You have it like this. So 2 dematerializes 2. Therefore, dy over dx becomes minus x plus y over x plus 3y. You can bracket it if you like. This becomes the final answer. Now, this is how to use implicit differentiation. This is how to solve problems on implicit differentiation. Don't forget, you use implicit differentiation to solve problem on implicit function. So we have come to the end of this class. In our subsequent class, I'm going to be elucidating more on other topics in higher mathematics. Please don't forget to like and share this video. You can follow me up on YouTube for more videos. Thank you.